Open the acoustic emission software, SWAE, on the computer. The device on-site operations can be roughly divided into the following steps. First, acoustic emission signal acquisition settings. Second, software views and location settings. Third, equipment debugging. Click the Hardware Sample menu and then click Sample Settings. In the Hardware Setup page, what we need to set up is the filter. According to the standard requirements of the detection purposes, the filter is set as 100 kHz high pass and 400 kHz low pass, which means the detection frequency range is 100 to 400 kHz. In the Heat Features page, we need to set the threshold, heat definition time, heat lock time, and peak definition time. Set HDT as 2000, HLT 20,000, and PDT 1000 microseconds. Click Waveform button to set the sampling rate and sampling length of the waveform. The sampling rate can be up to 10 MHz. When the standard requirements are met, it is a more balanced choice with 10 times of the detection frequency range. Let's set it to 4000 kHz. Other settings and options such as the synchronization mode are kept as default for this test. Click the Saving button to enter the file storage settings. It shows the file path and the file name to be stored in. Be sure to check the Save Acquired Data option. Set the maximum file size and number as big as possible depending on the size of your computer memory. For other settings, keep it as default. After the hardware sample settings, set up proper views based on the test requirements. Click the View menu and then click Merge, and the software will clear the default views. Click Split and move your mouse to draw the table size. For example, 2 by 2 for a total of 4 views. After left-click to confirm, 4 blank views are created in the view area. Click on a blank area and choose the view types on the top. First, create 2 basic and commonly used data views, data table and waveform graph. In the third view, select the correlation graph. In the setting area of the correlation graph on the right, you can set the x-axis, y-axis, and the display mode of the correlation graph. For example, the default x-axis is the channel number, and the y-axis is the heat number, which represents the comparison of acoustic emission hits received by each channel. Additionally, multiple correlation graphs can be set, such as the amplitude and time diagram, which represents a trend of amplitude changes over time, and it is often used for background noise acquisition to better determine the detection threshold. Finally, build a location map. According to the LPG cylinder, select cylinder graph in the location wheel option. In the cylinder setting, enter the relevant parameters, such as diameter 400 mm, cylinder length 700 mm, which means the vertical spacing of the upper and lower rods of the sensors. The number of rods is 2, and there are 3 sensors in each row. This time, the bottom part of the tank is partially detected, so no end caps is selected. The event setting and location setting can be set later in the machine debugging stage.